As you already know, ontologies and RDF vocabularies can model any domain of knowledge, from the well-known pizza ontology or any ontology about food to music ontologies or even ontologies about accidents in hospitals. They can represent general knowledge or highly technical knowledge, as you can see in the examples in the slide. Then they can contain thousands of concepts or just dozens of them. But in any case, ontologies represent and structure knowledge. Where is this knowledge? Well, knowledge is in our brains, or if we are not experts in the domain, in the domain we are modeling, we'll have to resort to books or to experts so that we can elicit that knowledge from them. All this knowledge is, in any case, expressed in natural language, the language that we speak and read. So, how do we learn about anything, about any topic? For going to information sources. For instance, if I'm Swedish and I want to find out what paella is, the Spanish paella dish, I would most probably access the Wikipedia site for that dish and identify the words, the terms that describe that specific dish. So I could say that knowledge is in the words that define and describe a certain concept or a certain area of knowledge. And those words are called terms. So maybe we should try to answer this question. What is a term? And how does it all relate with ontological engineering? Okay, step by step. Would you consider lens a term or a word? Let me tell you that there is no clear borderline here. If we look up the word lens in a general dictionary, we obtain a general definition for that word. But if we search for a definition of lens in the optics domain, we may most probably obtain a more specific and restricted definition. And that's the difference between words and terms. Terms are words that have specific meanings in specific domains of knowledge, and those meanings deviate from the meaning the same words have in everyday language. So the set of terms that define a given subject field are called terminology, the terminology of a certain specific area or subject field. But terminology is also the name given to the discipline that studies and identifies the terms of a domain, and it is also the set of principles for term compilation. For example, IBM has its own terminology, which means that the terms they use in their reports, technical documents, in their day-to-day work, in their internal communication, in the end, have a specific meaning, a meaning which has been agreed and defined internally within IBM. Yeah? Does this ring a bell? For instance, as you can see in the slide, ABC means here activity-based ghosting, but it may mean something completely different in a different company. There is therefore hardly any area in an enterprise or other specialized organization where terminology is not used. On the one hand, terminology is of fundamental importance as it represents specialized knowledge at the level of concepts, which are the basic units of thinking, cognition, and terminological data, those terms, are the main content carriers to record, to manage, to represent, to disseminate, to communicate or transfer specialized information and knowledge. On the other hand, there is comparatively little awareness for this importance, even in the quarters of the specialists being the primary creators and users of the terminology of their respective subject fields. So, the object of studying terminology are concepts, terms, and the relations between terms and definitions. So, at this point, I'm sure you have already identified many similarities with ontologies, right? Now, how do these terms relate to concepts? And we are coming closer to the main point of this lesson, namely, how does it all relate with ontological engineering? For objectivists, and because of practical reasons, we may want to accept this view that says the way in which we organize the world and relate terms to concepts looks like this triangle. The link between an object and its corresponding designation or definition is made through the concept, a higher level of abstraction. So I think we could claim that terms are the entry point to concepts, are the way we have to comprehend the world that surrounds us. So now, the next question, how do we define concepts? In terminology, concepts shall be considered mental representations of objects within a specialized context or field, as you can see from the ISO definition. Concepts are seen as units of thought, units of knowledge, and units of communication. But we shouldn't forget that concepts are influenced by social and cultural circumstances given at a certain moment. So this can lead to different classifications in the conceptual system. But this would be another topic. So back to our main purpose. How do we define concepts? Concepts are described according to their common features, properties, or characteristics, either by intension or extension. What is intension? A set of characteristics which make up the concept. So in the case of winter, winter could be defined as having low temperatures, ice, wind, snow in polar countries. So that would be the intention, the characteristics that define that concept. And then we have the extension, which are the totality, which is the totality of objects to which a concept corresponds. In the example there, the concept planet would include Mercury, Venus, Earth, Mars, and so on and so forth. Okay, so here again, I bet you have heard about these in previous modules, right? So you can see the difference between concepts and instances. So when defining concepts in ontology development, you will identify the main properties that describe that concept. And you will also identify the individuals or instances that comply with those properties. So once we have identified and defined concepts, we see how they relate to other concepts in the same domain. And here we can talk about three main types of relations. The general specific ones, the partitive relations, and then ad hoc relations of the domain, so associative relations, cause-effect relations, and so on and so forth. And we will also want to capture this information in an ontology. So, can we now answer the main question posed in this video? How can terminology or language resources in general help us in the development of ontologies? I hope so. Well, I think we have already seen many similarities between terminologies as a type of language resources and ontologies. So one obvious answer would be yes, terminologies can help in building ontologies by directly reusing those resources and transforming them into ontologies. But apart from terminologies, there are many other language resources we can resort to when developing ontologies at certain stages of the ontology engineering process. Or we can even reuse a resource to a certain extent to develop an ontology, or we can also use language resources to enrich available conceptualizations with linguistic and terminological data so that they are better documented and described in natural language and can be used in subsequent tasks, NLP tasks, data mining, content analytics, sentiment analysis, etc. Do you want to get more details on this? Watch our next video.